Hello and welcome to eSpeaks, the podcast where enterprise tech gets real. I'm your host, Corey Noles, and today we're going to dig into a shift in workplace computing. AI-ready PCs built with Snapdragon X series processors. Joining me today is Craig Tellalian, Director of Field Application and Customer Engineering for Enterprise Compute at Qualcomm Snapdragon. How are you, Craig?
I'm doing well. Thanks for asking, Corey.
Oh, good. So today, what we're going to do here is we're going to kind of unpack how this new architecture can boost productivity, slash IT costs, and even trim your carbon footprint in the process. So let's dive in here. So Craig, why does Snapdragon believe 2025 is the tipping point year for AI-ready PCs?
Yeah, no, great question, Corey. So there's a couple of kind of forces at nature right now. You have Windows 10 is going end of life for commercial customers in October. So pretty much if you're not already on Windows 11, you need to make sure you have a plan to get you onto Windows 11 by the end of the year. So naturally, there could be scenarios where customers will refresh their PCs. What we're likely expecting is customers will not just do an in-place upgrade, but they'll physically buy new hardware.
Yeah.
So there's an opportunity right there where if you're looking to future-proof your environment and you're going to lean in and really consider AI-capable PC. And then you also, you have a lot of hardware that was consumed during the pandemic. And, you're looking at now that hardware being 4 or 5 years old. So that's another critical moment for PC refreshes as well.
Which in an AI world means will be a decade.
Yeah, absolutely.
That's interesting. You hear a lot about them and they're all over the place. So Snapdragon X series processors run on what you're calling Windows on Snapdragon. And it's the first, if I'm correct, non-x86 on Windows. So what's fundamentally different about the Oryon CPU and NPU design compared with the traditional x86 systems that most enterprises run on today?
Yeah, no. So we are definitely a unique architecture. We're a RISC-based architecture. It's a reduced instruction set. Our Snapdragon silicon is what is prevalent in most of your high-end premium Android mobile handsets today. And when you have to build around a low-power island where you have you have limited real estate for thermals, limited real estate for power, and just in general, you want to keep the devices thin and light. You need to kind of rethink how you architect the processing power. And so what we've been able to achieve in the mobile handset space, we're now bringing to the PC. And when you compare that to x86, when Windows PCs first came out, they were desktop computers. They were connected to the wall. There was no such thing as running on battery, no such thing as a laptop or a clamshell. So the ability to take what was a traditional PC experience and make that be more mobile, that's where the x86 architecture is really starting to, run into some limitations or obstacles that we naturally, being that we come from the mobile space, are better equipped to handle. And so part of that infrastructure, part of that design is where we basically incorporate dedicated engines for different types of compute processing. So your CPU is obviously the brains of the operation that does most of your system processing, the applications and so forth. But then you have a term known as a GPU, graphics processing unit, and that is something people are very familiar with. But then the third engine here is an NPU, a neural processing unit, and that's where all of those AI workloads are handled. And by decoupling those three engines, we're able to only consume the power when we need it for that specific engine. And it's different than x86 architecture where you pretty much throw everything at it. And when you throw everything at it, the challenge is you're going to have to throw a lot more at it to cool it. Yeah. And then obviously once you unplug from the wall, you're throwing a lot more battery power at it, which leads to challenges longer term.
That makes a lot of sense. I hadn't considered that. So what kind of AI tasks run locally on the NPU today, and why is that valuable from like a privacy standpoint or latency cost?
Yeah, no. I would say a lot of the first wave of AI experiences from Windows that Microsoft delivered was anchored on the video and the audio stuff. And when you kind of go back to the pandemic period, everybody was working remote, so it was natural to turn on your video, right? Turn on the camera, and the challenge was you didn't have a way to efficiently process things like background blur and auto framing or noise suppression or echo cancellation. What ended up happening is the Windows and the applications were having to push the full system and GPU resources. And that led to devices overheating, devices slowing down from performance standpoint and so forth. So Microsoft sort of took a step back and said, how can I re-architect this capability so that I offload some of those tasks to a system that's not the GPU or the CPU? And that's where the neural processing unit, the NPU, comes into play. The NPU is able to handle a lot of the inference models. When I say inference models, it's basically knowing when to blur my background and knowing that I'm an actual human. And when I move my hands, it knows what to blur and what not to blur. Knowing when to suppress the noise of a dog barking in the background, right? Those things are, in essence, being handled within a local language model, a small language model that's running on the device. But the key is that processing doesn't have to go through the CPU or the GPU. It can get offloaded to the NPU. And so for us with Snapdragon, it's terrific because regardless of what size, number of cores of your CPU you have from Snapdragon, you have the same NPU performance of 45 TOPS, which can handle those seamless tasks like background blur, noise suppression, echo cancellation, and so forth. So that's table stakes. That typically is 10 TOPS or 15 TOPS of required processing power in the NPU. Where it gets more interesting is as you start to introduce more complex inference models that can run locally, that's where you start to exhaust what is capable of sort of an entry-level AI PC. And you're going to start to see more experiences from ISVs, from Microsoft get introduced that I can push the envelope of my NPU without having to compromise my CPU or my GPU performance. So Corey, if I can embellish, a great example would be a security application that is running in the background, like a security agent that's trying to detect fraud among the user, trying to detect where data may get compromised. That needs to run constantly. It never turns off. Well, if it's always running constantly and it never turns off, think of the strain that's going to put on my CPU. It's going to tax my CPU. It's going to make everything slow down. Things are going to get hot. That type of a task can now get offloaded to the NPU, which only requires drips of power, and it doesn't impact any other overhead that the CPU needs for the key productivity applications that you're used to running.
Oh, wow. So your GPU and CPU stay free to do what they need to be working on, what they're good at.
Yeah, absolutely. And that's where a lot of the innovation is going to come. It's going to come from these very surgical specific experiences from not just first party Microsoft, like within the Office suite or Teams or Zoom, for example, but it may come from a lot of these security ISVs that they typically have to always be running low level processing consistently. They can never turn off.
Yeah. Oh, wow. So Snapdragon says that your X series processors can hit the same CPU scores as Intel Core Ultra while drawing 70% less power. What does that translate to in real IT OPEX and refresh cycles?
Yeah. So first of all, you think about, again, where we come from. When you have a smartphone and you're doing tasks on your smartphone, it doesn't run any faster when it's plugged into the wall versus when you pull it out of your pocket, right? It runs the same. Performance is uncompromised whether you're plugged in or unplugged. And so for us, that's what we've been able to achieve with Windows on Snapdragon, which is an incredible feat. But then what happens is when you look at the traditional x86 architecture, they're able to achieve fairly comparable with the current gen, Lunar Lake and AMD Strix. They're able to achieve close to that same performance curve when you're plugged in. But the second they unplug, what ends up happening is they need to slow down in order to conserve battery life. So the performance threshold drops down dramatically. In some cases, it's 50% or more.
Because it's trying to manage your performance.
Right. And there's always going to be a compromise with x86. If you want higher performance, it's going to come at the detriment of battery life. If you want longer battery life, it's going to come at the detriment of high performance. We have a zero compromise architecture, which is phenomenal. But more importantly, we're pulling when we pull power, we're pulling it at literally half the amount of wattage of most traditional x86 architectures out there. So when I do my electricity bill at the end of the year, if I am an ITDM, if I'm pulling 10 watts of power versus maybe a x86 PC that's averaging 30, 40 watts, I amortize that over a year, over 5 years. My bill to Con Edison or the local electricity company is going to be a lot higher in my x86 architecture. So that's one. The other thing is, when you think of running on battery, I'm draining my battery less frequently. It takes me longer to go through the battery cycle, which means the cycle count is occurring. I'm doing fewer cycle counts over the span of a year, 5 years. So I now stretch the lifespan of my battery, because most batteries have a known life expectancy defined as a cycle count. And so it will take me twice as long or 3 times as long to hit that cycle count threshold where the battery begins to degrade, versus traditional x86 is going to hit that cycle count probably in the first year or two, where you traditionally have to replace a battery.
So in addition to longer battery life, in addition to longer charge, you're also looking at this extension of life of battery.
Absolutely, yeah. So it's a great carbon footprint, eco-green story, because being so much more power efficient, battery efficient, I'm stretching the lifespan of the battery itself much longer.
Oh, wow. Yeah, that's interesting. I had never considered that, but that makes a lot of sense. That's some really interesting stuff you're doing. Can you share any lessons from Snapdragon's own rollout of 100,000 of these Windows 11 PCs and the BDS Connected Solutions field pilot?
Yeah, so obviously the architecture is different, right? It's still Windows, but the OS kernel is not the same OS kernel that an Intel or an AMD uses, because they're an x86 architecture. Ours is a RISC-based architecture. And so part of that requires that an IT environment, they need to understand, how do I manage and support a different Windows architecture? Because what happens is there are going to be certain applications that will need to be specific to the Snapdragon environment that won't necessarily be compatible with the x86. And those are typically your security level applications, things like encryption, data loss prevention, endpoint protection, VPN. Those scenarios need to basically be identified and addressed. So typically, you won't see a customer go completely, full in on Snapdragon. It's a slow burn where they want to be able to get comfortable that as they introduce this new architecture into their environment, they can validate and confirm that they have all the proper, processes in place to manage and deploy and support any driver updates, application updates, and so forth.
So how are Microsoft Copilot, Dell, Lenovo, and other OEMs shaping this next wave of Snapdragon-powered enterprise devices?
Yeah, so what we've seen is with the introduction of Snapdragon X series middle of last year, Dell, HP, Lenovo, Microsoft Surface, Samsung, Asus, Acer, they've all started to enhance their portfolio along their x86 offerings. And in most cases, you're looking at multiple device options, form factors available from that OEM. And so we're at a point now where when I look at mainstream PCs, your traditional clamshell environment, anywhere from the 12 or 13 inch size screen up to maybe a 15 inch, we have at least one or two offerings running Snapdragon from each of those set OEMs.
Wow.
And that's going to continue to grow over time as we introduce next gen of silicon and so forth. And it's a way to offer an alternative to what has been a fairly successful momentum that Apple's built with their own, M1, M2, M3, M4 architecture, where when end users need a device with high performance, great battery life, that's thin and light, some of them have actually turned to Apple. So they would prefer to stay on Windows if they can, but they haven't been able to find a viable alternative from x86. And that's where we come into play. And for that user profile, for that scenario where the individual isn't sitting at their desk 24/7 with unlimited power, where they care about thin and light, great thermals, a great battery life, great performance, we become a great option for that enterprise to consider.
I can see that. That makes a lot of sense. So speaking of Apple, where does Snapdragon bring that unique value versus, say, Apple Silicon or the latest x86 pieces without getting into a full, spec sheet war?
Yeah. And, you're going to always have your community of folks that love Apple and that are fully committed to the ecosystem across, iPhone, iPad, and Mac. What we've seen with the majority of enterprises that we speak to is if they've started to embrace Apple in their environment, it's begrudgingly because they couldn't find an alternative from Windows. But the preference for IT is to stay on Windows because it provides a much more streamlined, known way to manage and deploy. There typically is going to be a trade-off when you have to introduce Apple into your environment.
Yeah.
You may have to use a separate tool like Jamf. You may have to limit the security tool set that is available. Apple definitely has a great story with regard to performance and what they promise. The challenge is Mac OS is a completely different environment than Windows, and most enterprises want to be able to stay within the Windows ecosystem, and that is obviously something Apple can't provide that we can with Snapdragon. It's been, I would say it's interesting as both Intel and AMD have started to enter the fray with their own Copilot Plus PCs. And just to clarify, right, Microsoft defines a Copilot Plus PC as an AI PC with an NPU that has tops of at least 40 or higher. There are other PCs that are called AI PCs, but they're not delivering 40 tops. They're delivering maybe 10 or 15. And in order to deliver the enhanced set of functionality that we spoke about earlier with these language models, you need an NPU capable with at least 40 tops or more. So I would just say, like, for Snapdragon, we're able to deliver across the entire Snapdragon X series line 45 tops of NPU performance, whether you're in an 8-core, 10-core, or 12-core version of our silicon. Wow. In the case of x86, their AI PCs, the mileage is going to vary based on whether they're running Lunar Lake or whether they're running a prior gen, and then you end up with the challenges we spoke about, which is performance cores, efficiency cores, trading off battery for performance. There's always going to be a compromise there that you got to deal with.
It is. And this is a thing I think it's important for people to kind of learn as we go forward because, AI PCs are still a relatively new space and really seeing a lot of new stuff coming out. And this is a big deal. Yeah, absolutely. So if I'm an IT director planning, a major refresh in 2026, what's the single pilot project you'd start tomorrow to validate Snapdragon in production?
Yeah, I'm gonna give a little bit longer answer here because I want to make sure. The first thing is I want IT directors to start to identify what is the company's overall strategy around AI, because what we're finding is that the IT client compute team isn't necessarily talking to the AI developer team, and what I mean by that is that the AI developer team is working on stuff in the cloud. And they're thinking about everything just goes into the cloud, and I have unlimited AI resources that I can leverage in an always connected environment. And the reality is that's not sustainable. That's going to lead to challenges around, power and energy consumption for the hyperscalers that are delivering that AI workload. But then it's also going to add to significant cost for that company that's using it. And then there's also concerns around, do I want to put everything into the cloud for security, privacy reasons? There could be issues around latency where the network may not be as fast. So I would say every IT director on the client compute side needs to have a plan around, how am I going to embrace AI at the edge? How am I going to run AI experiences on my PC? And if you can start to put together that plan, then that will impact the decisions you make today, because even if you don't have a solution to run locally on the edge today, you will in the next 2 years or 3 years.
Right.
And so you need to make sure you're future-proofing your PC acquisitions today so that they have enough capability on the NPU side to handle those AI workloads if and when you start to deploy them locally on device. And, if I could just embellish, Corey, for a second, like we have, some customers that are already on that journey with us, where they're looking at a concept known as RAG, Retrieval Augmented Generation, and they're basically saying, I can't allow ChatGPT or Copilot to be my single source of truth. I want my own company data to be the single source of truth. And so the RAG concept basically lets me say, okay, here is a PDF document, or here is a set of unstructured data that is only proprietary to me as the company. And I'm going to point my language model to that data. Well, if I could have that data all run locally on my PC and process it, and now my employee can do all those workloads, whether or not they have a good internet connection, and they can all do it in the safety of that encrypted PC that your company's managing, and you don't need to be paying out money to the cloud hyperscalers for all those workloads and so forth. So to bring this all back, the single pilot project, I would say, is what is your strategy around AI edge compute on device, and make sure that not only you identify what that strategy is, but you're future-proofing your PC investment today with AI-capable PCs with at least 40 TOPS.
I agree. I think we're at a point where that time is here, and it's smarter than ever right now to be thinking a couple of years ahead and looking at what you have access to today, and assuming that will continue to grow and that your need for it will as well, and planning accordingly. And I think this is a great way to do that.
Yep.
Well, that wraps us up for today. Craig, thanks so much for joining us. It's been fascinating.
My pleasure, Corey. Love to do this again. So
Absolutely. We sure will. Well, thanks to Craig and Snapdragon for the insights, and to you, our listeners, IT leaders across the U.S. and Europe even, for tuning in today. If today's episode sparked any ideas for your next device refresh, subscribe to eSpeaks wherever you get your podcasts. Drop us a rating. Till next time, stay curious and stay ahead.